In this video, we're going to talk about object-oriented programming. So this is the next chapter in our book and something we haven't talked about before, okay? So before we get to object-oriented programming, let's talk about what we've been doing so far and kind of other things we could have been doing, okay? So the styles of programming that you see today are first going to be, why it's doing that, that's really weird. The first is procedural. There we go. So procedural programming is what we've been doing so far for the most part. It's focused on the procedures or actions that take place in your program, okay? What we're getting ready to move forward with is called object-oriented programming, and that focuses on objects, which we'll define here in a second, okay? And then the final one, I can make it do that or not, apparently not, is functional programming. And that requires special languages, and it's function-based. You don't need to know anything about functional programming except that it's a thing, okay? So the idea behind object-oriented programming, we're trying to represent real-world entities and their interactions in our code directly, okay? So what we've done before is just use data structures and try to go that way. So let's think of an example where we're trying to keep track of students in a class. Okay, so you can have a list of the students, you know, that would be okay. But then if you wanted to keep track of their majors, maybe another list that you would have to coordinate the numbers, the index numbers, don't know. Well, what if we need to know their social security number? And what if we need to know the classes they've taken? It gets complicated really fast, okay? So the idea of object-oriented programming is we're going to create a student object, okay? And the student object will contain both the data about the student, which we're going to call attributes, and what you can do with the student, or what functions act on that data, okay, which we're going to call methods, okay? So that's the idea, okay? So this turns out to be a pretty useful way to program, and much, if not most, of programming done today is done through object-oriented programming, okay? So Python allows us to do object-oriented programming. If not, we wouldn't be talking about it in a Python class, okay? So when we're looking at object-oriented programming, there are some principles that we need to talk about that are going to help us out here, okay? And the first of these, I don't know why I can't do more than one list in this, but apparently I can't. I could do that, which is really ugly. Let's see, kinda. Okay. I'm using Colab for stuff it was not meant to do, okay? The first is encapsulation. So encapsulation then just is the idea of bundling the data or the attributes with the functions or the methods into one unit, okay, which is an object, okay? So in addition to that, we have the idea of abstraction. So abstraction then is simplifying complex reality by modeling classes based only on their essential features. So we're going to ignore everything that's not essential for us, okay? Another term we need to talk about is inheritance. So inheritance basically is a mechanism that allows you to create new classes. We haven't talked about classes yet. So you can create new types of objects based on existing ones, okay? Which promotes reuse, code reuse, and just makes the development of things easier, okay? And then we have the last one is polymorphism, which the last two of these we'll talk about later. It allows objects of different classes to be treated as objects of the same class, okay? Again, don't worry about that so much for now, okay? But that's kind of how that works, okay? So one part of encapsulation I didn't talk about is it allows for what we call information hiding. Okay, and that prevents access or change to attributes outside of the class, okay, if you want. I mean, you don't have to, but that's what it will do if you want to do that. We'll talk about that today as well, okay? So the way this works then, we have to create a class first. So a class is used to create objects, okay? So what that means is, so I like to think of it, if objects are cookies, then a class is a cookie cutter, okay? So if I want to create a student class, okay, I create the student class, I define what attributes I want, what functions that I want. I can then, or what methods that I want, I can then create objects of type student. I could say Bob is a student. I could say Sally is a student. Whoever I want can be a student. So Bob and Sally are objects of type student. Student is the class, okay? So the class is the blueprint or the template. Okay, it'll define the structure and the behavior of the objects. Okay, so it's the instructions for creating those objects. Okay, before we get into the coding, let's just talk about some benefits of object-oriented programming. Okay, first one is modularity. Modularity means that it's easier to manage and maintain code because you're gathering all these data structures and crazy stuff, these lists and variables, into pieces that are easier to deal with, okay? Reusability, which means that the classes and object can be reused in different parts of the program, okay, which is a good thing. It can certainly lead to simplicity, okay? Simplicity in our coding, okay? It's easier to create an object of a type class than it is to manage all of those variables independently, okay, all that data independently, and also extensibility. Okay, you can extend the existing classes to create new classes that have new features, other stuff that you can do, and that's just a good thing, right? That makes it all very helpful, okay? So the next thing we want to do here is we want to create some code for this, okay? So I'm going to start here. We're going to do, since we're coming off of our group project on CRAPS, let's do a die class. Okay, and want to model a single die. Okay. So when we're thinking about this, we have options. The sides could be fixed to 6. That's the most normal die that we see, but we don't have to do that. Okay, we can make a more general solution, which is a better solution. And instead, we're going to allow the sides to be variable. Okay. So now we have to, things we have to track now. Okay, so our attributes then are going to be sides for one, since it's not always set to 6. Okay. And we're going to have to worry about the value. Okay, the value is just whatever the current number that's facing up, basically. Okay. That's all we need. If we were doing a different object, say we're doing a car class, the car may need a license plate number and a make and a model and maybe a mileage, whatever you're trying to do. An employee could have, first name, last name, employee number, salary, all those things. All those are attributes, okay? Now we have to think about the methods we need, okay? So the first thing we'll talk about in a minute, we have to have initialize, okay? we have to have a way to initialize the class. Okay, so we'll talk about that. Every class has an initializer. Okay. In this case, we're going to want to roll the dice, right? So this is going to return a random number between 1 and the number of sides. And we're going to set value to this. Okay, so that's what we're doing there. Okay. And because we eventually want to hide the value away, we're going to have a get value function, okay, which just will return the current value. Okay, we can't just print that direct because we don't want someone to be able to just change our value randomly. We want to go through, in fact, we want them to do it randomly. We want them to do it through the roll function, not direct, okay? So information hiding is going to come in there, okay? So this is our game plan, okay? So we have our classes die, the attributes are sides and value, and our methods are roll and get value, okay? So to start this code, we're going to first start with our import random because we know we're going to need it. If anyone can tell me why I always type in an E at the end of random, I would appreciate it because I always do. I don't know why. Not if I'm writing it by hand, but when I type, I do. Okay. So the keyword is going to be class, whatever the name of the class is. Okay. Not the name of any object we create, but just the class. We're going to call it die. We usually put a capital letter for that. You don't have to, but it's worthwhile. Okay. Notice it has a colon at the end. It's a block. Okay. So I'm going to go ahead and put this. Note also that I'm defining the class before I get into the main function where I call anything. Okay, you want it up front. Okay, when we call main the way we're calling it, it doesn't really matter, but it's just good practice to get your classes out of the way. In fact, classes are often stored in separate files that you import in. Okay, but you don't have to do that. Okay, so the very first function that we have to create is our initializer. Okay, so inside of this, I'm going to have my function, define a function. There's a special name, underscore, init, underscore. Okay, that's the shift and the thing next to the 0 on my keyboard at least. Okay. So another keyword we use in Python object-oriented programming is self. Okay. Self refers to the object that's calling this. Okay. So if we're going to create a new object called D1, then self would refer to D1. Okay. It's included in all attributes, or sorry, all methods that we create. So all the functions we create have that in there, but you don't have to worry about it. Okay. We're going to pass along sides, but we're going to default it to 6. Okay. We can still do something different if we want, but if we don't say anything, it will automatically make it side 6. Okay. So that's what comes into the function. And then to refer within the class to, or to set up, we haven't set up yet, our attributes, we'll do a self dot. Okay, that's how we know it's part of the class. So self dot sides is equal to sides. And that may look a little funny. They're both sides, right? This sides refers to this variable that we're passing in. Okay, this sides, because it has self dot, refers to the sides variable that's attached to the class. So these are not the same thing. We're setting the class sides equal to the sides variable we're passing in. If that makes you queasy, you can just do this and it works just as well. Okay. But I'm okay with this. Okay. So that's the first thing we have to set up. The other thing we have is a value. Okay. I'm going to set it to 1 here. You can also set it to none. Either one's okay. None just means nothing, but we can set it to the default to 1, but make sure that we actually roll it before we do anything else. Okay. So now we have our class. If we had our def main down here, we could create an object. I could say D1 is equal to die, name of the class. That's it. That's good. Okay. I could say D2 is equal to die 10. That'd be good too. 10-sided die. Okay. I should be able to run that. I don't think I need anything else. We'll see. Maybe I do. No, it seems okay. It's not doing anything, but we have that at least. Okay. I'm going to leave them both. It's six-sided to make it simpler, but you can do that whatever you want. Okay. So we have the other functions we haven't talked about yet. So we can't do anything with our role, our die yet. So let's define our role. All functions defined inside of a class have to have self. That's the way it goes. Okay. And I have to refer to self dot value. Okay. Not just value. Value would not be wrong, wouldn't give me an error, but it would point to some local variable I'm creating rather than the variable that we're storing, okay, in our class. Okay. It's going to be equal to random dot rand int between 1 and self dot size, whatever that is. Okay. In our case, it's 1 and 6. That's it. It doesn't have to return anything because we're setting it directly. So as far as the scope goes, any class variable, as long as we put the self in front of it, can be used in any of our methods, and it's perfectly okay. Okay. Last thing I want to define is our get value. It also takes a self and no other parameters. These functions could take parameters, just this happens not to. Okay. Which is going to return the self dot value. Okay. We haven't yet talked about making our attributes private, so we wouldn't need to do that, but we're going to go ahead and set it up now and then talk about it later. Okay. So that should be it, right? That's set up everything we said we were going to set up. Okay. So now we can go down here and try this out. And then I can say d1.roll. Okay. That's going to change the value of D1 from 1 to something else. Could change it to a 1 as far as that goes. I mean, I guess we could always do something crazy if you want, like -9 there. Okay. So that's going to change the value. We don't have to return anything. We don't have to capture it because we've created now, we have two objects, D1 and D2. Both objects are of type class. They're sitting out there. They both currently have a number of sides variable, which is currently 6, and they have a value variable, which is currently -9. When I do d1.roll, then d1 will have some other value, somewhere between 1 and 6. Okay. I can then do a d1 dot get value. Okay. And that is just going to return that value. So I'm going to either need to print that or set it as a variable, which is probably not a good idea. So let's go ahead and print. So I can go ahead and print the 1 is or rolled a, whatever you want. And then that d1.getValue, which is the function. Okay. I need one more of those to close that out. Okay. I can do the same thing on D2 just to show that it should still have that initial value. Both of these. Okay. Doesn't like something. D1 string object. Oh, that's because I didn't put a comma there. Okay, so I've got it. That was a typo. I did that a lot. I don't know why. Because they're next to each other. Let's try it again now. Yeah. So D1 rolled a 4. D2 didn't roll anything. So these, I really should say the value of those. Okay. If I change this to a D1.roll, D2.roll, okay, we get two different values. They're different every time. Okay. So again, hopefully see the value of this. We didn't have to do anything new to create a new value. I could create as many dice as I want. Okay. So that can be pretty handy. Okay. But we still have an issue here in that there's nothing special about value. Okay. So I could just say D2 dot value is equal to 100. 199 over 2. Okay. So if I do that, you see that the value of D2 is 100. Okay. And that blows up everything, right? We're trying to keep a 6-sided dice. So we don't want that to happen. Okay. We have to protect that. Okay. So we protect that in our variable names by prepending the name with underscore underscore. Okay. And that's it. That's just Python's way of saying this is a protected variable. Okay. But it means we have to put those underscores everywhere, there and there. Okay. So now if I try to directly print out the value, okay, so if I want to print D2 dot underscore underscore value, okay, it's going to give us an attribute error. Can't do that. Okay. So now we should be glad that we went ahead and did the get value, so we don't have to worry about it. Okay. Okay. So that's all we have to do. So unless there's a really good reason, make sure it still works when it does. Oh, it did not. Why did it not? It's not changing that value on the roll. I did something wrong on the roll. Oh, that's what I didn't do. I would have liked that to give an error message. Because I basically just set up a new variable randomly, but Python doesn't do that for you. So now we're getting it working correctly again. Okay, we've protected this information. So again, new rule for programming: every attribute should be private, unless there's a really, really good reason that I can't even think of one right now. Okay, so we're going to make all those private, which means we can only access them through a get function of some sort. Okay. And again, the reason we do this is we can control things. We can keep changes from being made that are not the ones that we want. Okay. So that should be a good introduction to what we're doing here. So just to review, we do classes, okay, so we can create objects. We do it to encapsulate data about usually some real world entity, but it could just be an abstract concept. We want the data, which we're going to call attributes, and the functions that operate on that data, which we're going to call methods. We're going to encapsulate that into one thing, okay, that we can then manage more easily, okay? So to do this, and then the information hiding comes in, and that we're trying to keep unauthorized access to the internal parts of our object, okay? We're choosing what we show to the world from our objects, okay? So here's our example. The class is the keyword class die. We now have a die. You have to define it before you use it, like a function. Using the def main doesn't matter. They can be in any order. I have to have my initializing function, okay, which in Python is underscore underscore init underscore underscore, no space between the underscores. Every function in Python takes self as the first variable, first parameter. In this case, we have comma. We're setting size equal to 6, which is the default value. You can make a die of whatever size that you want. Okay. And then when we're referring to attributes inside of our functions, we're going to use a self dot. Okay. So in this case, we've got self dot underscore underscore sides, which creates an underscore underscore sides attribute, which is a protected variable. Okay. A private variable. We're setting it equal to the size we set in as a parameter, 6 by default. Then we're setting the self dot underscore underscore value. It's protected as well, equal to -9 first time. Okay. We then have two other main attributes here. The first one's roll, which is going to change the value, underscore underscore value, to a random number between 1 and the number of sides. Again, self dot underscore underscore sides. Okay. Then we have a get value function. Because they're private, I can't directly print out the value. I have to print it out from within the function. Okay, which again, if it's something you don't want people printing out, then they can't do it. You've blocked them. Okay. So that function takes a self, as all functions do, takes no parameters, and just returns the current value of self dot underscore underscore value. Okay. So then in my main program, this is going to create an object of type die called D1. That should have been an octafork but not a dash. Okay, that's what that's doing. And this is creating an object of type die called D1, D2, sorry, the next one. I'm then rolling to change the value of both of those. I'm printing out that, okay? You can do that as many times as you want. Okay, keep rolling. Got a bunch of rolls, okay? So that's the basic idea. Note that if we were to do a type here, so let's print type of D1, it's going to tell us that D1 is of type die. Okay, it's a die. Okay, which makes sense. Okay, so that's a lot to digest. So hopefully this all made some sense. If not, make sure that you ask questions. Okay, we'll do some examples of it in class. But this is an important concept. As we move into next semester, you should be signed up for the C++ class now, CSC 1180. If not, do that. We'll be dealing with objects again, and you'll get object-oriented programming a lot here in your studies. Okay.